Nicholas Noire, someone dropped up who is on the flight, he will just land this evening. And I'm also very grateful for this enthusiastic audience, also from all parts of India, and also some from England. And we have people from government laboratories, private laboratories, and academia, new PhD students. And there are some minor changes in talks and speakers due to some last minute difficulties. I think today, the last talk was supposed to be by Professor Maria Hexel, but instead we are having Jakub Herman give a lecture, but that will be via internet. Maria's talk will be switched with Jakub Herman's talk tomorrow. Most importantly, I want to thank Tango, which is a Marie Curie initial training network. Special thanks to Maria for arranging and working so hard to get this workshop going. Maria will give a brief introduction to Tango right after this. I also want to say that Tango there's something special about it. It's a gender balanced network. So in this workshop also we are making an effort to be gender balanced. And I want to thank the NCCRD, National Combustion Center for Combustion Research and R&D, and especially its chairman, Professor Chakravarti, who has been an enthusiastic supporter of this concept. We are trying hard to get everything working. I hope it works. But if something is not working, please let us know. We'll be very happy to try it better than our best to get things going. But if there are any problems, feel free to let us know. And about the workshop itself, we are having the entire range of starting from classical measurement techniques to optical diagnostics, modern analysis. We will cover the entire spectrum, and I think some of the speakers, especially Simon Hofter and Chakravarti, will show some very recent results. And we will, indeed, most of the conference is focused on thermoacoustic instability, but I'm sure you all agree that flow of dynamics is a very important part, and we will have a little bit of flow of dynamics as well. Just a minor thing, there are a lot of lectures, and so we would like to keep time. So I think, and we are recording the talk, so it will be best to keep the things on track. So it will be nice if the questions can be at the end. So for a 1 hour talk, the speaker speaks for 45 minutes and 10 minutes of questions and 5 minutes for the changeover. So that's all I have to say. Welcome to IIT Madras again, and enjoy the talks and have a good time here. If there's anything we can do, please let us know. And now I invite Maria to speak a little bit about this how to tango, and she herself is a dancer. So.
Hello everybody, and welcome to Tango. I thought I would say a few words about Tango to give you an idea as to what this is. Tango is a consortium of partners from various different countries, mainly in Europe. That's United Kingdom, Sweden, Germany, Italy, Netherlands, and Belgium. But we also have an Indian partner, which is IIT Madras, and Professor Suchi from IIT Madras is our lead scientist within Tango. And these partners provide research training for young researchers, typically research students, PhD students, and these students are funded by the European Commission. They are funded by the European Commission, and also the project itself is funded by the European Commission. The total budget that we have for this project is just over 4 million euros. So that covers the cost of about 15 PhD students and all the sort of training expenses, their salaries and all the training expenses that are associated with them. The whole project lasts 4 years. An individual PhD student will be there for 3 years. And we have a sort of a joint project. The overall theme of it is Tango, which I'll explain in a moment. And each PhD student has a sort of a mini project within that overall project, which is forming the basis of their PhD thesis. spaces. As I said, the research area is TANGO, which is an acronym. The T stands for thermoacoustic. The A, TANGO, stands for aeroacoustic. The N stands for non-linear. The G stands for green, green as environmentally friendly. And the O stands for orifice structures. So the full title, I have to see if I remember it fully, is Thermoacoustic and Aeroacoustic Nonlinearities in Green Combustors with Orifice Structures. And this is a 4-year consortium. We have regular scientific workshops. This is our second workshop in the series, and this one is on experimental methods in thermoacoustics. And I'm very pleased that we can hold this workshop here at IIT Madras with the well-known Professor Suchi. And I welcome you all to this workshop and hope that you gain a lot out of it for yourself from a professional point of view and maybe also from a networking point of view. Thank you very much.
Thank you, Marie. In the next 15 minutes, I think we can introduce each other and very briefly tell the name and where you are from and what's your interest. So we'll start with Sakura. Press the button so that everybody.
I'm Satya Chakravarti from Aerospace Engineering IIT Madras. I got in combustion.
Santosh Chandra from the University of Science. I work in combustion as well.
I'm Susanne Moore from KTH Sweden, Aeronautical Vehicle Engineering Department, and my interest is aeroacoustics.
Hello everybody, I'm Michael Weiler from German Technical University of Munich. My main interest is combustion.
Hello, my name is Rizzo. I'm from Salernitana, Italy.
My name is Rick Raumenhorst. I'm a Tango Fellow at IFTA GmbH in Germany.
I think the introduction will get over in 1 minute, I think. You can say a little bit about, more about your interest, because the idea is that we have big tea breaks and coffee breaks, so I mean, if people can know what you're doing and so on, then there can be more interaction. So I think it's okay to say something more about the work you're doing, because we have time till 10:30. And the idea was to really introduce each other, not just this. Because name you'll forget. Research area people may remember.
Hello, I'm Nandini Mukherjee. I'm from Keene University. I'm one of the Tango fellows, and I work in the field of aeroacoustics, mainly in the mounted acoustics and acoustics.
Good morning, my name is Paul Higgs. I'm from the Deutsches Museum in Munich, Germany, which is one of the largest museums of science and technology in the world. I'm involved in the Tango project as a communication outreach expert.
Hello, good morning to all. I am Pankaj Wahi from Mechanical Engineering at IIT Kanpur, and my interest is basically in the field of nonlinear dynamics and how nonlinearities could be. What does nonlinearity do to various systems, especially high-dimensional systems? Like, so I am not really a thermoacoustics expert, but a few years back I started collaborating with Mr. Sujit, and we did some work on extracting information about the system dynamics from experimental data and some theoretical modeling. And my basic theme of research is how to come up with some reduced order models for systems so that they replicate the entire behavior that the system is showing, and those reduced order models can then be used for developing control strategies. So probably I was the one who took the longest time, but I thought that is what you expect from it. But thank you.
Good morning, everyone. I'm Venkat. I work in Honeywell Aerospace Labs in India here. Most of the work which I do is on gas turbine engine design and development. That's what India here we do CFD analysis of gas turbine compressors, Honeywell gas turbine compressors, reducing the emissions, improving the pattern factor, mixing studies. So my role mostly in the combustion team in Honeywell is to come up with different mechanisms, reaction mechanisms for predicting the emissions and, if possible, find ways to reduce it in Honeywell compressors. Thank you.
I'm Chinthya Mukhopadhyay from Mechanical Engineering Department, Jadavpur University. My interests are combustion dynamics and atomization in space. In combustion dynamics, we work mostly on gas turbine combustors and pulse combustors.
Hello everybody, I'm Wei, also from KTH Sweden. I'm also the Kanto fellow. What I'm doing now is the coupling between aeroacoustic and small acoustic.
Hi, myself Sri Krishna Sahu. I'm from Mechanical Engineering Department. I work on development and application of different optical diagnostics for sprays and two-phase flows and good atomization.
My name is Sarit Satyan. I work in the area of compressible fluid flow and microscale nanoscale transport phenomena. I'm a faculty in nuclear mechanics department of AIT Madras.
Hello, I'm Balaji from Metaform Technologies. I have attained my PhD with Professor Satya in the field of combustion stability. We investigated combusting flow through a backup failing step with the interaction of flow and acoustic. Thank you.
Hi, I'm Mahendran from Metaform Technologies. I recently started working in acoustics. So that's why I'm here.
Hello, good morning everyone. Myself is Ram Kumar Sharma. I am from TVRL Chandigarh. I am working in the design and development of pulse detonation engine.
My name is Umesh Kumar. I am working on the presently in pulse detonation engine and also I work on the liquid propulsion system. I face the problem in combustion stability in our liquid propulsion system and how to overcome this combustion stability problem, that we are working on that one. So it is in every engine, it's in the solid rocket motor, liquid rocket motor, and even we are doing now first detonation engine work, then also we are facing. So we want to overcome on this issue. So we want to get some idea from this work, that is our interest.
Hello, I am Rajesh Ramakrishnan, working in Honeywell Technology Solutions in Bangalore. I work in gas turbine CEP, currently interested in global combustion market.
My name is Rajesh KK. I am from one of the research laboratories of DRDO, DRDO. We generally involved in design and performance prediction, testing of solid rocket motors, which are being used in various missile systems of our country. The problem is that instability is something which we have read in textbooks earlier. Now this instability is becoming a day-to-day affair in our activities, because many of our rocket systems, because earlier we used to design rocket motors deliberately low performing. Now we are becoming smart, and rocket motors are high performing rocket motors. So we have also entered into the regime of instability. See, if you look at this instability, especially solid rocket motor instability, we try to fix it using some technique without knowing the physics. This is one thing. So from this workshop, what I am looking for is, because it is basically experimental related measurement. So in terms of controlling the instability, the measurements from which we can understand more about it, more physics about it. This is what I am looking from this workshop. Thank you.
Good morning, everybody. My name is Sundar. I'm from GE Aviation. and my interests are primarily in lean personal processes and commercial applications. I'm interested in this particular workshop because we want to know what Europe is doing. We know quite a bit what US is doing. We really like to know what Europe is doing. We have an incipient collaboration with TUM, and I would like to know, how this workshop can help us know and get into understanding what the European Union is doing with commercial instabilities.
Hi, my name is Yugandhar. I work for GE Aviation, the commercial team in GE Aviation, and our focus is basically on design of aviation combustors as well as method development, and that includes developing methods and for
Hi everyone, my name is Habib, working with GE Aviation and primarily designing combustors. I'm interested to know more about combustion instability, especially the predictive, what is the state of the art of combustion instability predictions. Thank you.
Good morning. My name is Shrek. I'm from GE Aviation. I'm involved in design and development of gas turbine combustors on Bridgeport technologies.
I'm Srijit and I'm from GE Aviation and I'm based in Bangalore, and I work in the field of gas turbine combustor design and especially on lean combustors, and I would like to know what is the capacity or numerical way of understanding combustion dynamics when it comes to the lean combustors.
Hello everyone, I am Varun. I am a faculty leader in mechanical engineering. I work in the area of solid rocket motors. I try to understand the steady and unsteady combustion behavior of solid propellants. And unsteady, I do research in both linear and non-linear combustion of solid propellants. And then using information in full motor simulations to understand how the pressure tank evolves through a simulation. I also work in the area of biomass gasification and combustion of fluid solids.
Good morning everybody, I am Paulucina Mahapatra. I just completed my PhD in multi-case law.
Good morning all. My name is Shomik Mahapatra. I belong to TSI Incorporated, and our company is a 51-year-old company just into optical diagnostic tools like LED, PDK and EVP systems. And as a special mention, I would like to thank the organizers for allowing us to be a part of this event. And of course, Professor Sujit, who is our first customer in India. Thank you.
I am Vineet Nair, a doctoral student with Professor Sujit. My interests lie in the field of diagnosing combustion instabilities in various propulsion systems and power generation systems. Thank you.
My name is Vinu Varghese. I am also a student of Professor Sujit. I work in studying the scale interactions, multiple scale interactions in a combustion system.
Hi, I am Mukund. I am also a doctoral student of Professor Sujit, and my areas of interest are combustion and thermal systems.
Good morning everyone. My name is Queen Stovichan, and I'm from GEO Munich. The focus of my project is study of thermoacoustic systems with heat exchangers. The objective is to study the instability driven by heat absorbers with powerful structures.
Good morning, I'm Alessandra Bigongiari, and I'm a Tango Fellow at Keele University, and my interest is in thermoacoustics.
Hello everyone, I'm Zlatan Fonat. I'm working in NMS International in Belgium, and I'm also a Tango Fellow, and I'm working on the numerical study of perforated plates with brazing and layers.
Hello everyone, my name is Antonio Bashkin Davis. I am from Eindhoven Technology University from Netherlands. I'm also a Tango Fellow, and just like Jonathan, I also work on sound attenuation using microperforated plates. Well,
combustors. And my main interest is to control the puttings on gas turbines.
Hello everyone, I am Kiran from Indian Institute of Science, Bangalore. My field of interest is hydrodynamic and thermoacoustic instability. So I am currently working on reduced order model for combustion systems. Hello, my name is Srinivas Kirti. I am a research assistant at IISc. I am working with Professor Santosh Chandra. I work on experimental work. I work on optical flow diagnostics in backward-facing step combustors or dumb combustors. The intention is to characterize the hydrodynamic instabilities in combustion instability, especially in backward-facing step combustors.
Good morning everyone. I'm a master's student at Indian Institute of Science in Aerospace Engineering Department. I've just begun my research in computations of combustion instabilities. I also have my interest in turbo machines and computations of turbulent flows in general. Thank you.
Hello, I'm Maria Hecker. I'm from Kiel University. I'm the coordinator of the Tango network. And research-wise, my interest is in fundamental thermoacoustics, I would say.
Good morning. I'm Gunilla Eknason. I'm from KTH in Stockholm, Sweden. It's very cold there now, so it's nice to be here. I'm the deputy coordinator of Tango. Research-wise, I work with aeroacoustics and aerodynamics. My research interest in aeroacoustics is in ducted flows primarily, looking on generation and scattering of sound. But we also do applications for external noise. In aerodynamics, I work primarily with vehicle aerodynamics, but also with aeronautical applications as well. I do simulations, no experimental work, so this is good for me to learn more about experiments.
Hi, my name is Nicolas Loiret. I work at Alstom Power in Switzerland for gas turbine engineering, and so I work in the combustor department, and I deal with pulsations modeling and reduction of pulsation in our gas turbine combustors. Thank you.
Hello, my name is Larry Lee. I'm from Cambridge University, where I work on the hydrodynamic instability of shear flows and the synchronization and nonlinear dynamics of turboacoustic and hydrodynamic systems.
Hello, my name is Edwin, and I'm a fellow at the Tango project. I work at KTH in Stockholm, and at the moment I'm doing experimental investigation of the cylinder area expansion with respect to the aeroacoustic properties, and especially the dynamics between acoustics and hydrodynamics.
Hi, I'm Ashwati. I'm from Kiel University. I'm also a Tango fellow. I'll be working on combustion system heat exchangers.
I'm Akhilesh Kumar. I'm working for Gas Turbine Research Establishment, which is a Ministry of Defense R&D organization, and I work for the design and development of the afterburner system.
I'm Ganesh from Gas Turbine Research Establishment. I am works in the area of afterburner combustion of the gas turbine.
I am Kuvirappan, Technical Director from Combustion Systems at GTRD. We are looking forward for input on the direction of experimental methods, which is available for combustor as well as afterburner combustion instability. We want to cooperate under FCCR. We want to establish the facilities to support our already initiated analytical work. Thank you.
Myself is Darpan Moya. I am working in the combustion department of the GTAD. We are looking at first time I think we are going to hear about how we are going to measure the cross tax in combustion systems. So I am very interested in this. Thank you.
I am Ashirvadam from GTRA. I work with Dr. Muthu, and we do have a screech in the afterburner. We are actively involved in Dr. Sujit and learning theoretical part quite a bit. Now we hope to have very good exposure to these experimental methods. So thank you for allowing us to be here. Thank you.
Lastly, Sujit, and I work in thermoacoustic instabilities, particularly the nonlinear aspect of it, and my recent work has been to look at the unifying features of thermoacoustic, aeroacoustic, and all kinds of instabilities, irrespective of the physics of the system. I think we are on good time with the introductions.